Hi there, thanks for joining us on Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. Great to have your company. Coming up on this episode, a new study from the Max Planck Institute shedding some new light on the Theia-Earth relationship, which might surprise you. And just when you thought it was safe to go back to sleep at night, 40,000 new Near-Earth Asteroids have been discovered. Only 40,000. And they're all coming our way. No, they're not. The search for life just got another a bit closer, thanks to some Cassini data. And 3i Atlas still making the news. We'll talk about all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And we rolled out the red carpet because he's back. It's Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. I'm actually looking for the red carpet.
Yeah, I rolled it back up again. It's
okay.
had a few moth holes in it.
Yeah, but glad to hear it.
Good to see you.
And you too. And, well, we've missed you. No, wait a minute. No, you've missed me.
Missed you.
One or the other.
Yes. We did have a few people starting to, I found in radio, if you're away for more than about 3 or 4 weeks, people started ringing the station and emailing to say, where's Joe Bloggs, or where's, this started happening with you, Fred. So,
oh, seriously?
Where's Fred? Where's Fred? What's going on with Fred? What happened to Fred? And funnily enough, I was able to say, yeah, I don't know.
We haven't seen him for weeks.
He just disappeared. Yeah. But no, he's back. He's back. So where did you go? What was the? Give us the precede version of your 7 weeks away.
3 weeks, leading one of Marnie's tours, which is the third big one we've done this year. Actually, after the Arctic in January and February, and then it was Western Australia in the middle of the year, and then this time we went to Japan. So we had a tour that took in interesting places like Osaka and Kyoto and Tokyo. And Marnie and I actually made a side trip down to Hiroshima, which is a place I've always wanted to visit. And I'm
me too.
Very glad I did. Very sobering place to be, but a welcoming city as well. It was a pleasure to be there. And then we wound up actually in Hokkaido, right in the north of Japan, where it was essentially coming on to winter. They get lots and lots of snow up there. It's a lot similar to the Arctic, even though it's at a much lower latitude. That was all fun. So we came back. We had 4 nights in Sydney at home in our own bed, do the washing, and then off again to a conference on dark skies in County Mayo in Ireland. We were in Ireland for about a week, a little bit more than a week. We did some touring down in the south. We blew a kiss to the Blarney Stone.
Oh, did you?
Yeah. I wasn't game to kiss the Blarney Stone because you have to be upside down.
Yeah.
Doesn't suit me at all.
No, we didn't do that either.
No, so we blew it a kiss, which is enough apparently to get the gift of the gab. And then, in fact, Blarney was a delightful place. It was the one sunny afternoon we had in Ireland, and it was lovely. Such an amazing castle, and the grounds picture perfect. Then we went over to Scotland, spent some time with my 2 daughters. Had a great time with them, took a weekend out. We all beetled off to St Andrews, where I was educated, a town that's very close to my heart. We had a great time there. Didn't do any golf, I'm sorry, but we did walk past the old course and thought of you with your golf clubs and that they don't float and things like that.
Yeah.
And then after that, we took the train down to Birmingham from Edinburgh, and that was pleasant. And at Birmingham, we got on a plane and went to Cyprus. In the eastern end of the Mediterranean, and we actually had a holiday. And 6 nights.
Found an observatory, a brand new one called Troodos.
Troodos Observatory, yes, we did. Marnie had checked it out, as she does with these things, and so we made a pilgrimage up into the hills, not very far from the highest point in the island, actually, Mount Olympus, but it's got its own little mountain, has the Troodos Observatory. We went up there. We went completely unannounced. They just had a tour group through, so there were 2 coaches which were just about to set off down this road that was slightly narrower than a coach, an angle of 45 degrees. If we'd been half an hour later, we'd have probably not been able to get there because these damn coaches going by. But when we arrived, they just got rid of all the coach party, and we turned up and said, we're astronomers. Can we have a look? And they said, oh, no, you'll have to wait till the next tour. But we managed to get hold of the events manager, who said, yeah, come in, let's talk about what we do and all the rest of it. We had a great time.
Awesome.
So that was very, very nice.
Yeah.
And if she's a Space Nuts listener, nice to have met you. I think it was Irena was her name.
Nice.
Greek version of that. And then came home. And we came home last week. And we're now jet lagged.
Yeah, it's hard to get over jet lag. I think it's an age thing, Fred.
Could be, except my other half is a lot younger than I am, and she's jet lagged too.
Just goes with the territory. Yeah. Well, I got a golf story for you. While you were away, I won a championship.
You did, yes. Yeah. Well done. So it was
17 years between drinks. Well, no, I came in the state championships. I came third on handicap and top 10. I finished ninth, I think.
Fantastic.
In the state championship. But then we had our own championship at Dubbo Golf Club the other day, and I managed to win one of those. So
that's very good.
And then today, just before this, I played in the Pro-Am because we're hosting the New South Wales Women's Open qualifying event. So I played with a young lass from Melbourne. Her name is Piper. I've gone blank. Anyway, come back to me. Lovely young lady, hits a really mean ball, and wishing her well. Hope she makes it to the New South Wales Open, and I'll be watching her career closely. So very good.
She beat you.
Gosh, yes. Oh, yes. Well, it was a teams event today, so we were technically playing together, but she outdrove us miles. Yes, yeah, she could hit it.
Interesting.
Hit it a long way, but just a pleasure, just a delight. We had a good day. We should get down to it, Fred.
Yeah, we should. Yes, we're not here to talk about golf, are we? Although it doesn't seem that way.
Not for a change. Our first story takes us back 4.5 billion years when our neighbouring world, known as Theia, smashed into us and all hell broke loose, literally and figuratively. But a new study has just been released from the Max Planck Institute that's shed a bit of new light on the Theia-Earth relationship. It doesn't sound like this was what we originally thought, just some random thing coming in and hitting us. There's more to it, the story now.
There is, yes. Sorry, Andrew, you broke up there, but I think I know what you said. The story of Theia, of course, this has been the principal theory for the origin of the moon for at least the last 60 years, when the Apollo astronauts brought back, 380 kilograms of lunar rock and soil, which are still being analysed. So Theia is the hypothesized planet. Perhaps protoplanet is a better word, because this was at a time when the solar system was still in its infancy, 4.5 billion years ago. And this object basically clouted the Earth. And we think that what happened in the aftermath of that collision was a cloud of debris raised from the surface of the Earth, went into orbit around the Earth and eventually coalesced to form the moon. And so we've had puzzles which you and I have spoken about a number of times as to why it is. Well, let me step back a bit. The first theory was that because this is a smaller object hitting a bigger object, so Theia is thought to have been half the size of the Earth to get the dynamics right. The Earth's the bigger planet. What you would expect is that the debris cloud raised from the Earth when the collision happened would be mostly made of Theia material. And that's been a puzzle for a long time, because most of the lunar rocks and soil have the same isotopic signature, which we've talked about before as well, the same isotopic signature as the Earth. They're identical to the Earth's rocks. And so that was seen as a puzzle. And then about probably 5 years ago or so, we did cover it on Space Nuts. Some Japanese researchers figured out that if the Earth was still effectively molten at that time, if it was still a magma world when the collision happened, then you'd get a moon that was formed largely of Earth compounds. So what has now happened is that a close examination has been made, and as you're right, it's the Max Planck Institute for Solar System Research, along with the University of Chicago. They've really honed in on the exact details of the isotopes in rocks from the Earth, the Moon, and meteorites, because they're part of the story too. And it's not just the sort of isotopes that have been looked at before. These are iron, chromium, molybdenum, zirconium, all these chemical elements. Their isotope data have been analyzed to look again at what we find, because yes, we still find that the Earth and the Moon have very similar isotopic mixes, but then you can identify some slight differences that are attributed to be isotopes that have come from Theia itself. So they can tease out what was Theia and what was Earth. And it turns out that when you do that, you still get a similar picture, that the isotope ratios on Theia were probably very similar to what they are on Earth. And that is symptomatic, if I can put it that way, of the Earth and Theia being born close together. And the reason why we think that is that when you look at the solar system, you find that these isotope ratios change depending on how far out you are from the sun. So if you've got two planets with very similar isotope ratios, then what you can deduce from that is that they were orbiting the sun close together. And that makes complete sense, because eventually they run into one another. But what the outcome of this research is that Theia was not just a random object that ran into the Earth in the early solar system. It was actually, if not a companion of Earth, but something in a very similar orbit. So, maybe we had Mercury, Venus, Theia, Earth, Mars as the rocky planets. Although that order, I've made that up, but that's the kind of thing. It's bringing Theia into the picture as something that would have been, maybe had it not collided with the Earth, it would have been the ninth planet in the inner part of the solar system. So a very nice piece of work, some very, very careful studies there that I think has raised a lot of interest in the planetary science community.
Yeah, I suppose that sort of confirms that it was part of the solar system and not just some random thing passing through, knocking us over in the process.
That's right, yeah. And I should just explain how the Theia remnants have been, the Theia isotopes have been determined. And it's by looking at things that we find in the crust of the Earth, because we know that the heavy elements would have already sunk to the center of the Earth when that collision happened. So when we find things like these molybdenum, iron, zirconium, things of that sort, we can infer that some of that actually came from Theia itself. And that's how the similarity has been deduced, along with looking at meteorite samples too. So you're right. It is not something that's come from another solar system like our current visitor, 3I Atlas. It's definitely a homegrown planet that we collided with.
Okay, and now it's sort of it's not a part of us. There's bits and pieces of it, but most of it sort of vanquished into the never, didn't it?
Yeah, a lot of it would have done, but some of it's in the Moon, some of it's on the Earth as well.
Yeah. All right. So yes, some new information from the Max Planck Institute about Theia being a part of the inner solar system. If you'd like to read about that, there's a really great article at scienceblog.com. This is Space Nuts with Andrew Dunkley and Professor Fred. Let's take a break from the show and talk about our sponsor, NordVPN. Now, if you care about your privacy online, maybe it's time to start thinking about a virtual private network, and NordVPN is by far the best you can get. It's one of the fastest and most trusted VPN services as well, helping you protect your personal data, secure your internet connection, and browse with peace of mind, whether you're at home or on public Wi-Fi. With just one click, NordVPN encrypts your traffic, hides your IP address, keeps your information safe from hackers, trackers, and snoopers. And you can also access content from around the world without restrictions, thanks to thousands of servers in over 60 countries. And as a listener of Space Nuts, you get an exclusive deal at nordvpn.com/spacenuts. Huge savings, plus an extra 4 months free when you sign up. It's simple, it's fast, it's secure, it works. Go to nordvpn.com/spacenuts and take control of your internet experience today. That's nordvpn.com/spacenuts. Don't forget the code word spacenuts and their 30-day money-back guarantee.
0G, and I feel fine.
Space Nuts.
Now to some really good news, Fred. 40,000 near-Earth asteroids have been discovered. Is that all? Is that all they could find?
Well, yeah. I mean, for a long time we've known of 39,999. Maybe not for very long, because we're discovering asteroids at a very prolific rate at the moment, and that comes about because we've got such good technology discovering them. And so, yes, this is a milestone that's been celebrated by ESA, the European Space Agency, and so they've put out a press release saying 40,000 near-Earth asteroids discovered. What do we mean by a near-Earth asteroid? It's one that approaches within about 45 million kilometers of the Earth, and that's nearly a third of the distance to the Sun. So it's when you say near, it's a fairly relative term. It's one with objects that can get within that distance of Earth. Then there's another subset of those, though, that we tend to call PHAs, potentially hazardous asteroids. And there are something like, I think if I remember rightly, it's about 2,500 of those. And they're the ones whose orbits cross the orbit of the Earth. And so they are potentially hazardous. And they're the ones that we keep an eye on all the time, monitoring where they are and checking forward in computers once we know their orbits, checking forward as to whether there's any likelihood of collision. The good news is that there's not. Over the next 100 years or so, we've got a fairly clean sweep of things, at least things bigger than about 140 meters across, and they can be very dangerous. They could be city destroyers or even state destroyers. So keeping an eye on those is important. And I think the reason why ESA has highlighted this is because it does highlight the whole regime of planetary defense. That's a very active area in astronomy and actually almost civil defense as well. It's not just astronomy that is concerned with that. I think I probably mentioned before when I was at the IAU a couple of years ago, I actually got myself into a meeting which was the Planetary Defense Agency talking about their next activities, which included a mock threatened planetary asteroid impact, and how all the services would deal with that. And from the astronomers right to the people who get the fire engines out to put out the fires and things of that sort. It was a very interesting thing to watch. So what it did was reassured me that we're in quite good hands. But yeah, the bottom line, 40,000 near-Earth asteroids known. The good news is always that the big ones, which are the most dangerous ones, they're the easiest to find. And we think we know pretty well all of the asteroids bigger than a kilometer, which would be dinosaur killers. They would wipe out, there'd be mass extinction objects. We think one of those hits the Earth roughly every 200 million years. It's 66 million years ago since the last one did, which was the one that wiped out the dinosaurs. Since then, though, we've learned a lot about not only about asteroids, but about how we might deflect an asteroid if there was one that could be shown to be on a collision course with Earth. And you and I have talked at length and with great enthusiasm about the DART mission back in 2022, the double asteroid redirection test, a really well put together experiment by NASA, which succeeded in changing the orbit of a little world called Dimorphos. And that's great news because we know that it's now possible to do that. And just as a postscript to this story, ESA currently has a spacecraft called HERA, HERA, on its way to Dimorphos to check out what the result of that impact was. It's going to study that little world, look at the debris that was raised by the impact, get a much better idea of whether it really is just a rubble pile, which we think it probably is, and just learn more about what an impact by a spacecraft does to an asteroid, because that's the key thing. If we're going to have to save ourselves one day by doing this, we want to know as much about it as possible. And if I remember rightly, Hera will reach Dimorphos, I think it's late next year. I think it's towards the end of next year.
Very exciting. Yeah, nice to get a follow-up on that story too, yeah. And, of course, this is not the end of finding these kinds of things, because the Vera C. Rubin Observatory in Chile it's not its primary role, but it will be looking for other near-Earth objects, and they expect it to find tens of thousands of them.
Absolutely. That's right. By this time next year, we might be talking about 80,000 or 100,000 near-Earth asteroids discovered. And of course, again, that's a good news story, because as soon as you discover one of these things, first thing you do is put its orbital elements into the computer, grind away, look at its trajectory in the future. And that is all done automatically. And if there is a need, the system will raise alerts that there could be a collision in a certain window in the future. So that whole process is really part of planetary defense. It's what's safeguarding us from the asteroid hazard.
Yeah. I read a story the other day. I think Vera C. Rubin took its first light, or I think they refer to it as was it June or July?
Yes, it was. Yeah, I think it's about then.
Yeah. So we're almost at the pointy end of that observatory kicking into action.
That's right. If I remember rightly, I might have these figures slightly wrong, but it was something like, was it a 10-hour set of observations they took, and they discovered more than 1,000 asteroids in that period. So, imagine what it's going to be like. This thing looks at the entire southern sky every 3 nights.
That's incredible.
Remarkable. Yeah, it's quite.
Yeah. We were so blessed to be able to get so much information out of, my brain's not working today. The other observatory, the one that's out in the L2.
Oh, yeah. You mean the James Webb Telescope?
James Webb. Gosh, why couldn't I think of that? But working side by side with Vera C. Rubin, this is just going to open up a whole new...
Yeah, that's right.
List of new discoveries. Yeah. Very, very exciting. If you would like to read about those 40,000 near-Earth objects... if you really, you can go to a horror movie instead, probably much more fun. But 40,000 near-Earth objects, you can do that through the European Space Agency website.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, this is a story that really excites me, because we've talked about this so many times, but this story I saw pop up last weekend, and we have been talking so much about the potential for life elsewhere. Haven't found it yet, but the signs are starting to build, particularly within our own solar system. And this particular story is one, again, where we have taken a bit of old data and reanalyzed it. And this involves the Cassini mission, which has been taking samples of the eruptions from Enceladus. And what they've discovered is very, very exciting.
It is. That's right. And yes, Cassini, it was active, if I remember rightly, between 2000 and I think, was it 2004? Yes, and 2017. So that was the period when Cassini was collecting its data. And as you've just said, we're still learning things from those data. And in particular, what has been identified is some previously unknown organic chemicals in the ice grains that Cassini flew through, which are erupting, as you said, from the ice geysers near the southern pole, the south pole of Enceladus, that little 500-kilometer diameter world, which is one of Saturn's moons, with the structure that we think is fairly common out in that part of the solar system, a rocky body overlain with a liquid ocean with ice on top of that, and the pressure of the ice is what's keeping that ocean liquid, along with the squeezing and squashing of the rocky part of the body by the tidal forces exerted by the giant planet Saturn next door. And Saturn, by the way, we've just gone through its ring plane. So Saturn, if you looked at Saturn through a telescope tonight or any time within the next couple of weeks, you won't see any sign of the rings because they're edge on to us.
Oh, okay.
Yep, just a little aside there. So what has happened is that we've known about these organic chemicals in ice grains, which we know come from Enceladus, because they actually feed into the outer ring of Saturn, something called the E-ring, which is a very diffuse ring. And we know that the material in that ring, the ice crystals in that E-ring, actually come from the South Pole of Enceladus. And those have been well analysed by Cassini and also by other observations. And so it was known that there were organics in there. But the question was, these ice crystals may have been in orbit, they may have been in space for centuries. And so their chemical structure might well have been modified, first of all, by the sun's ultraviolet radiation, which tends to change chemistry, and the solar wind, the wind of subatomic particles that comes from the sun. That too can change the chemistry of particles, grains of ice with their organics on them, the organic chemicals. It can change their chemistry. And so there was always a question whether these quite complex organic chemicals that were identified in the E-ring, whether they are telling you that that's how the ice crystals were when they were spat out from Cassini's South Pole. It puts doubt on it. And so what this new analysis does is looks back to one of the fly-throughs of Cassini through the ice plumes back in 2008. Cassini flew through the plume at about 18 kilometers per second at a height of about 20 kilometers above the surface of Cassini. And so the ice crystals that it passed through only a few minutes earlier were actually water in the ocean of Enceladus. So these are fresh crystals of ice straight from the ocean. In other words, they're effectively samples of the ocean water. And what they've succeeded in showing, what the scientists who have done this succeeded in showing, is that the chemistry is still there. The complex organics are there in this fresh ocean spray, as they call it. I love that idea. Yeah. It's an ocean spray, but it's ice crystals. And there's a whole list of things like esters, aromatics, heteroatom-bearing organics. These are chemical terms that I'm not that familiar with because chemistry was not my strong point. But these chemicals are, yes, they are there in the ocean of Enceladus. And what that has done is raised, again, the possibility that living organisms might exist in that ocean. And that because these chemicals are, as we keep on saying, the building blocks of life. Yeah. So just maybe there's something swimming around in the ocean of Enceladus that we are yet to discover.
Yes, and wouldn't it be exciting? And hopefully in the not too distant future, we'll be able to confirm it. I think people are starting to get very confident about the possibility, though.
Yeah. Yep.
Yeah.
That's right.
So fingers crossed. But the signs are starting to really build. And I even though it'll be probably one of the most exciting things ever discovered, should we succeed in finding evidence of life elsewhere, we also probably shouldn't be surprised, because water we know is prolific throughout the universe.
Yeah.
We know there are probably exoplanets orbiting almost every star in the universe. It stands to reason that somewhere out there, there's got to be some form of life, even if it's only microbial, or krill.
Krill would be exciting. Green slime is what we're likely to find, I think.
Green slime? Green slime will do.
Green slime would do it. That's right. It would indeed.
Indeed. If you'd like to read up on that story about the latest from Enceladus, you can find it in the journal Nature Astronomy.
Space Nuts.
One last story in this episode, Fred, and it's a bit of an update on 3I Atlas, the exo comet that is currently doing its thing. It's doing whatever it wants, really. But it's sort of reappeared, and they're getting some great pictures of it, not only from Earth but from Mars. And some of these photos are extraordinary.
Yes, they are. When you look at them, they're a little bit underwhelming until you realise that they've been taken by telescopes not on Earth, but in one case on the surface of Mars, but also from Mars orbit. And there's a little bit of a story to this, because these images were taken when the interstellar comet 3I Atlas made its closest passage, closest flyby of Mars, basically. 30 million kilometers of Mars, that's quite a close approach compared with the distances that we are from it on Earth. And that took place actually nearly 2 months ago, in early October. But what's held up the release of the images is the US government shutdown, which prevented these images being spread to the world.
He spoke about that at length.
Oh, can you?
Previous episode. So, I think we're pretty well squared away on the issue. But he had colleagues that were so badly affected by that, because it's the basically no income for as long as the shutdown existed. It's a very, very difficult situation. But so we know why NASA couldn't do anything at the time.
Yeah. So that's right. So, but we now have these images revealed now that things are up and running again. And perhaps the best one has come from the HiRISE camera on board Mars Reconnaissance Orbiter. And that's quite a detailed image of Comet 3I Atlas with a short tail and its coma. That's the region around the nucleus where material is outgassing and shining because of excitation by the sun. There's some interesting images from the MAVEN spacecraft as well, which has cameras on looking in the ultraviolet, and in fact it's got a spectrometer on that allows you to split the light up into its component colors. So we see the glow of hydrogen actually from 3I Atlas, photographed by the MAVEN spacecraft cameras, and the MASTCAM camera on it's MASTCAM Z, it's called, on Perseverance on the surface of Mars, actually managed to capture a very, very faint image of 3I Atlas against a background of stars. It's faint because that MASTCAM was never designed to do astronomy. It's all designed to navigate on the surface of Mars, but yet it's managed to catch a picture by being pointed upwards, obviously, at this celestial visitor. So the hope is that as these images are analysed, Andrew, we'll find out more about 3I Atlas, maybe even to get a good measurement of how big its nucleus is, the icy component that gives rise to all this luminosity. The last I heard was that the thinking was it was in the region of 20 kilometers across, which is large for a comet nucleus, but I think the jury is probably still out on that. Might find more from these measurements.
So how much longer will 3I Atlas be in our vicinity?
Quite a while. It's not, it's I think it passes closest to Earth this month, if I remember rightly, and then we'll be receding. It has passed its closest to the sun, and so it certainly brightened up when it did that, which is what you expect. As it leaves the solar system, we'll continue to track it with the world's big telescopes. Probably the James Webb will have a few more looks at it, and so I think we're going to be observing it for several months yet.
Very good. All right. Yeah, it keeps making the news, and why not? I mean, it's one of those things like this. It's only one of a handful of these things that we've found, but it's starting to look like this is not an uncommon thread.
That's right. And I think, once again, harking back to the Vera C. Rubin telescope, we're going to find more of these when that telescope comes online. We're probably going to have we've got 3 known interstellar objects now. It'll probably be 20 by middle of next year. Yeah. Who knows? It'll be quite extraordinary.
Indeed. All right. You can read more about the images that have been taken of 3i Atlas, and you can see them too at the universetoday.com website. Fred, that brings us to the end. Thank you so much.
It's been a pleasure, Andrew. I've forgotten how much I miss my weekly dose of space nuts, so it's good to be talking again.
It's good to have you back. Thank you for deciding to return.
Yes.
Even without the red carpet. Yeah. Oh, and by the way, that golfer I played with today, Piper Stubbs from Melbourne.
Oh,
Piper
good.
Stubbs.
Look up for the name.
Yeah. She studied at college in the United States and played collegiate golf over there.
Very good.
She's finished now, and she qualified as in political science. So
very good.
Yeah. Quite a bright young lady. And thanks to Hugh in the studio, although he couldn't be with us today because he heard there were 40,000 near-Earth asteroids discovered, so he built himself a bunker. He won't come out. And by the way, if you would like to become a patron, by all means, jump on our website and find out all about it. I know there are difficult times, and we would never expect you to spend money to listen to us. It's a free podcast, but people choose to, and there are multiple options these days. So if you want to become a patron, you'll get a commercial-free edition of the podcast. So if you'd prefer to be commercial-free, this is the way to do it. You can do it through Patreon, Supercast, Spreaker, and Apple Podcasts. They all do various payment options. If that's your thing, if it's not, just forget everything I just said. And don't forget to visit us online while you're there, or the Facebook group, the podcast group on Facebook, very active, and you can talk to each other about anything you like to do with space and astronomy. That's it for this episode. Join us again soon when we do a Q&A episode, and looking forward to having you join us then. From me, Andrew Dunkley, until next time, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.